how on earth are we going to find the length of this line? It feels like we don't have enough information to solve it. All we know is that this is a square, despite it looking a little bit wonky, and that this line, this diagonal across the square, is a length of 25. So what is this going to be? This semicircle feels like it could be anywhere. One thing that will be useful to solve this is knowledge of circle theorems. And specifically, if we just ignore like these parts of the line, we know that when we join up either side of a diameter of a circle with a point of it on the circumference, that it's going to form a 90-degree angle, which is very helpful. And then the next step that we want to start considering is how we're going to relate these two lines together. And what we could potentially do here is try and form some triangles. So if we just draw a line, drop a line down vertically from, that's meant to be a straight line. If we drop a line down vertically from the top of the square to the bottom and put the right angle there, and then drop a line horizontally, we might notice these triangles look a little bit similar. But are they identical? So in order to show that they are identical, we know that they share this 90-degree angle. We'd need to show that they share one more angle. So how are we going to do that? If we consider this angle here inside this triangle, let's just call it x. We want to be able to somehow connect it to the angle inside of our red triangle. So if we consider the quadrilateral, let's just label this up with A, B, C, and D. If we consider the quadrilateral ABCD, we've got two 90-degree angles, which sum to 180. So there are 180 degrees left to be split across these two angles. So this would be 180 minus x. And now, of course, because angles on a straight line sum to 180, this angle would also be x. Well, that's fantastic. And then because we know that these sides must be the same length and all of the angles are equal, that's enough for us to conclude that these two triangles are congruent and thus share all the same side lengths. So that the hypotenuse of this one is 25, of the blue one is 25, the hypotenuse of the red one must also be 25. If you like that, let me know in the comments.